Okay, guys, I think we can start. Welcome to the 5th webinar in the Fundamental series. As always, I will start from reminding you what's the process of this webinar, and we're gonna talk about what we did yesterday, just briefly, and today we're gonna cover the APIs. We're gonna talk about the integration and the message queue, so really important topics. They are not very long, so we should fit all three today. And yeah, let's start sharing. Let me just open the application. There you go, and share. So first, as always, the training process. So I would try to give you as many examples as possible. If something is not clear, you can use chat. If you have any questions, please use the questions and answer tab, because there I can track the questions that I already answered or that still needs my attention. I will be answering only the questions I can answer immediately. If there will be any question that needs a little bit more explanation or needs for me to check something, we can postpone them till tomorrow when we're going to have longer question answer session, or you can post them to the Slack channel and somebody will help you as soon as possible. Today we should have 2 breaks, like 10 to 15 minutes each, probably 10 minutes. So one after the first and the second presentation. As always, the slides and the recording will be shared with you, so you don't need to take any recording by yourself. And there is a Slack channel designed especially for this webinar. If you have any questions, any issues with your environment or with setting up the application, or want to discuss something from the webinar, please use it and we can discuss it there. I'm also posting this link to the chat, so you can click and go there right now and save it. So yesterday we talked about the ACLs and the import-export. Both of those you're probably gonna use in most of your applications, because integration nowadays is used by really 90% probably of the applications. Either you want to integrate with some ERP, or you need to send some information after the order was created, or sometimes you just get pricing from different service, or you can get inventory management not hosted by yourself internally. You just need to fetch those inventories and you just store them in Oro. So really gonna use those a lot. And if this is the Oro is the sort of true, then your API probably is gonna have to be customized to suit all your needs or your functionalities. And then we also had the import-export. And actually this import-export we're gonna also talk a little bit today, because it's a part of the integrations when we think about the data integration. And also at the very end, today we're gonna talk about the message queue. And then I will try to enable Xdebug and show you whole process, how the message queue process, and when the import-export starts in the message queue, and go step by step through all those steps to visualize this for you. Okay, so let's start from the API. So we are using Friends of Symfony REST bundle and the Nelmu LP doc bundle. They are very nice and we use them, for example, in our sandbox. We are following JSON API specification. They are, to remind you, links here are mostly for you. I'm gonna follow some of them, but not all of them. They are mostly here. Then when you're gonna get those slides and you would like to check something, you can follow the link and get more information, more detailed information that I'm gonna provide you here during the presentation. By default, in the previous version of Oro, we were supporting WSSE authentication, which is not very popular. And right now, starting from 4.1, the default and recommended one is out. You can still get it for the 3.1, as you remember, as an extension, install and use it. I will show you how to configure it and start using it for your application. Also, we support ATOS. So I will also demonstrate you how the API response looks with and without it. requires user API key. This is true only if you are using WSSC authentication. If you are using OAuth, this is no longer true. And for custom entities, so those that we created in the second day through the UI, or for dictionaries or enum fields, the API is enabled by default. For the entity like you created for the naming type, you will have to enable this, but I will show you how simple it is. So, in my opinion, API is one of the most customizable part of Oro. Really, if you understand the idea of the processors and the order of them, you can customize the requests or responses any way you like. And if this is still not enough, you could always write your custom endpoint. So really, there is no limit of what you can provide in Oro API. So it's based on the chain processor. So your request gets to the main processor and it executes processors in the specific order that you can always check and modify. And your data goes from one to another with a shared context. And then there is a response, okay? So you can inject new service, new processor in any of those places and modify the behavior of your API. So there are a few commands. As always, a recommended way would be to go to the console and just type bin/console and grep by API, for example. And you will see some commands for the API with the explanation what this is for. As you can see, the first one here, is to generate WSSE header. We are not going to demonstrate this as this is not the recommended way anymore. Right now, we're gonna go with the auth in most cases, and I will demonstrate you this one. Then we have two for clearing the cache, one for the API itself, the second one for the API doc, which is used in the sandbox. And we can debug the API, which we're also gonna do actually during this presentation. If you would like to see additional ones, there is a documentation for this. And actually, the API documentation was one of the most robust. So actually, you can go here, one level above, and you will see there is a really, really big developer guide, and you can check filters, headers, how to, and get really all the information you will be looking for about the APIs. And it's already migrated to this doc. Previously, it was kept in the bundle itself. Now, we have Sandbox. This is something very useful if you would like to check how your API works, what are the responses and the requests. So to open the Sandbox, this is a simple thing. You just go to the training application or to any application, and there are two sandboxes. The one that we're gonna focus right now, which is the backend one, and also there is a separate sandbox for the front store API. I will just show you the front store API, but it's not going to be covered today. Probably it will be part of the, I'm not sure, of the commerce webinar next week. So once I'm here in the admin panel, I just add API doc, API/doc. Okay, it took a while. Actually, there's quite big DOM document generator for this HTML page. As you can see, this is the REST API, and also we had the old one, plain API. If you would be using older version of Oro, this was the one that was loaded by default, and you were switching here to the REST. Right now, the REST one is the one that is loaded first. So you've seen actually the plain API demonstration when we were talking about the search. And this is no longer being expanded, right? So we just keep it because we have users that are using it. But right now, the main focus, of course, the new REST API following the JSON API structure. Okay, so you can see we have some entities here. For example, we can find the user. We can open this. Here we have some actions and also for related entities. I can also toggle this one. I have the documentation where I have the information of the output columns with the description, and also about the filters that I can use, and so on. So this is really quite well documented, and about the statuses that can be returned. And also here I have the sandbox, so I can use it. I can provide some additional information and just try it. As you can see, this is get list, so I do not have the ID. I can click try, and I get the response. Okay, this also I can toggle. This is a very good way to debug your application, to debug your API, because you can just add some breakpoints, execute the request from here, and that's it. And also, you can see that by default, we have no ATOS header added. So if I remove this one, you see that right now there is no links to the entities or any related entities. So I can remove this from the header, send the request again, and right now I have the links added. So link to the entity that is returned, and also for each relation I have the links. Okay, so they are here. By default, they are disabled in Sandbox. Oh, excuse me. So authentication through auth, it's quite simple to configure, and once you get it, you just generate the token and use it. So first of all, what you would need to generate the private and the public keys for your application. It's not for the user, it's for the application. I had them generated, and I have them in my var directory for the application, right? So you have the training, this is your application root, and I have both keys generated here. You can modify those paths. By default, they are here, but if you actually search for those values in the IDE, you will see that they are configured in our two-server bundle, and those are private key and the public key. So you can modify them in the config or in the MPP YAML, right? Any other configuration value if you ever need to. So you can change the path or you can change the file name. So if you go to your application, you should go to user, preferably yours. I've already added this one right before the demo, but if you would like, you should just click the add application and add some name. You can make it active or not, and this is important. And also there's a disclaimer here. You will be presented client ID and the client secret, and this is not being stored in this way anywhere in the application, so you will not be able to regenerate this. So if you do not copy this right now somewhere, it will be lost, so you will need to remove your application and generate again. Okay, so please copy the client secret, otherwise it will not be possible to get it back. Okay, actually I don't need them because I will be demonstrating on the application already created, but this is just for you. So that's it from the application perspective. So we generated some auth application for our user. This is how it looked. And right now, once we copied the secret, we can generate the token. I'm not sure what you are using to test your APIs. I'm using the post one, I really like it. So let me just open this. And here I created the training collection. I created the webinar environment, and for it, I've configured few values: the URL, URL token, client ID, and the client secret. Okay, I can close them now, and I can get new access token here. So I have the authorization, I have auth2, and now I can get new access token. If I would not create those environment variables, I could just provide the full URL, client ID, and the client secret here, but this is really convenient to create those variables and then just use them, okay? So I can put some token name, then I have the grant type, and it should be client credentials. Then I have the URL token. So the token for the URL As this is, you can see my value for my environment. This is just the URL of the application / OAuth2 - token, which you can actually find here on the slides. Okay. So here you should not provide just endpoint like /OAuth2 - token. It should be full URL, which is just removed from the screen, and then OAuth2. Then we have client ID, client secret, and I can click request token. Before I do this, let's try to call the request without the token. So you can see I have the URL of the application /admin /API /users. So this is also the same that I had here in the sandbox. So you can remember here I had admin /API /users. Okay, so I used the same URL, and the answer here is 401, so unauthorized. I did not get any information because I need to be authorized to perform this request. So now I can get this new access token, requested, it was granted, so I have the token here, and I can just use it. So I click use the token, it will be added to my request, I can send, and I have the information. So really recommended way for me is you can create the collection, you can store some requests, and you can modify, change them. And of course, you can do this in Sandbox. Here, it will be just faster. It's surely faster than the Sandbox functionality. And also, you can test your out too, as probably your users or clients will do. Okay, so this is how you configure the application, and then you can just use it. Okay, this is actually what you've seen. So now, what actions do we have by default? Here is the list. So we have get list, create, update, delete list. And I'm not sure if this is already included in 4.1.2 or it will be in the next version, but also there will be update list because we already had a lot of requests about it. So first of all, the API is based on the entity. And for specified entities generated automatically, like we said, those custom entities or enums, and it uses custom entity aliases, which is very nice because we don't want to specify this fully qualified class name. We can exclude whole entities or just some fields. So for example, you can have order information in your API, but you don't want to share the total. So you can just exclude the total from the API or even just exclude it from specific actions. So you can still have it in the put, but removed from the get. Then we have some filters and sorters, just like, for example, in data grids. We have the validation, and we have X include header, which already actually seen because no hatos is one of those header usage. So for the entity configuration, first of all, we may exclude it. Then we really strongly recommend to add some documentation. Please remember that sometimes your clients, they will be not aware about your system, so they will need it. You can also set max results for this specific entity. You can set what is the default order when you return the list of records of this entity. You can add custom form to process, create, and edit. And also for those forms, we'll be able to create custom listeners. So those listeners will be only for the APIs, not for the forms if you use them in the system. And if you have some delete logic, for example, you have some soft delete, or you need to also check some other conditions, you could create the delete handler. For each of those sections, there is a documentation, which includes all the keys that you can specify for this specific section, and also some description. If you would like to start with the API, this will be part of the practice. This rather short one. You would go to the resources. Oh, excuse me. Config Oro API YAML. And as always, you have some hints here. Okay, so you can specify entity aliases, you can use the relations, I do not have the entities because once something is already used from the hints, it will not be hinted again. So probably if I remove this, I have the entities back here. So this is if you are wondering why it was not giving the entities as a hint. And then I need to specify the class name. This should be also hinted. Yeah, you can see I have the entities here. So I can use it from the hints. And then I have the keys. So I have the sorters, filters, fields, and so on from the documentation. So to just enable the API for your entity, all you have to do is to add this section. And probably like this, and then API for this entity will be enabled. That's it. Then, of course, you need to, probably you will have to customize it a little bit further. So first of all, and this is where you start usually, you have some field configuration. So you might exclude specific fields, you might change this data type, you might map it to other properties. For example, you have some property in the system, but in your client system, it's called differently. So you might create some like a different name in the API and then just map it with the property path to the yours one. And data transformers are used here. So if you are familiar with the Symfony forms data transformers, here is the same thing. So you can change the data that is stored and the data that is presented to the user. And we can have meta property, which also is part of the practice. As you can see in the configuration, there is a different section, right? So we have entity configuration, and it looks very similar, but right now we are in the fields configuration section. So if I just go to the IDE, I have some field, I have some, so we had the title, right? So I can use title, it's hinted, and then I can just exclude it from the API. And also we had the format, again, and here I can change the description. Let's see if it works. So webinar demo description. Probably I should run the command to create the API doc. And also I will create the API cache. And by the default, by the way, here you don't have to use the full names. If this is like there is not ambiguity in the shortcuts you use, he will know, and here you can just go this way, for example. If there will be two comments matching this, of course, it will not work. So right now, you can check the sandbox. Where do I have it? Oh, I had it here, sorry. So it was for the user naming. I have user namings. And before refreshing this, you can see I have just ID and the format. I do not have the title because I excluded this, and I have the webinar demo description, okay? So it's very simple. And again, if you have the plugins configured, the hints are great help. Now the meta property. So some of the fields are not in your entity. You may add some custom fields and then they populate their value. It's gonna be also the part of the practice, but let's see. You just create some field, just specify its data type, and say this is meta property true. So this is not the property of the entity. You just create this, and then you need to populate this value using the processors. And as you can see in the results, I have the ID, and I have the meta, and I have the attributes. So in attributes, I have the title only, sorry, the format only, And in meta, I have some, in this case, name example. And how we got this value, I will show you soon. So then we have the filters configuration. It's another section. So those may be excluded, of course. We can specify the data type. Now we can specify multiple values for the filter. So allow array true, and then in the comma separated, we can use them. Excuse me. Let's see this one, how it works. I think it was already enabled in some entities. And yeah, you can see I can, because the phone is a collection for B2B customer, I can use array and specify few phones to search for specific customer. Okay, this could be the example. And it might also filter different property using the property path. Now the important one is the operators. So and here you can see that for some of the APIs, sorry, so some of the filter types already have the defined list of operators that will be there out of the box. So for the Boolean, I don't have because it's just true or false, so just equal. But for the integer, I have equal, not equal, greater, so smaller, smaller, equal, and so on, right? If, for example, I have the operator that, sorry, the filter that I know if I enable like, it will be very much hitting the performance, I can just remove it for the list. I can narrow down the list for this specific filter. For example, I can say that for category, despite the fact it's just the integer because we use the ID, it's make no sense to look for the category with ID greater or equal than 2, right? So for the category, I will have the possibility to use only equal and not equal filters, right? And this will be for category node in actually catalog bundle. Okay, so this is how I can narrow down the operators for each filter separately. Then I can also create the custom filters. And the important thing, if I have the index for given field, the filter will be added by default. Again, we have exclude. This is actually true for all the configurations. We can allow array. We can set the the range, different type, different operators, and always there is quite good example here. So we already configured the entity. Then we can configure the fields and the filters. Then we have the sorters, which is the simple one. So just as you saw in the data grids, to sort using this specific value, the field. And also by default, it will be added for every field that have index created for it. Now, the very important one is the actions configuration. So you may exclude action, but also for each action, you may configure the fields. Okay, so this is important. For example, what I said in the beginning, we have the order, and for order, you may not want to return the budget, but you would like to have it in the expose it in the API for the post request, right? So in this case, I could create the action configuration. So here I would add actions. Now I can define what action I would like to use. And let's check our one. So here, as you can see, I had the fields excluded, but I can include it in the get. So again, fields, title, exclude false. Let's clear the cache. Okay, let's go to the sandbox. Excuse me, is this one, and refresh it. I have user namings, and okay, I did something wrong. Let me check it. Oh yeah, I changed it for the get, not for the get list. This here is get list, right? Because I'm not using the specific ID. Here I have the get one, so it will be this one. I see that the title is here also back in the documentation, right? Here in the get list, I did not have it. And in the get, I have it. And probably if I specify some ID, I have it also in the attributes, okay? So this is a very important thing to remember, that you can configure something for entity, and then configure it for the action, and action always takes priority, okay? So if I enable or disable something for the action, I did opposite for the entity itself, the action configuration takes place. So used in many cases, you want to be able to get some information through the API, but you don't want to expose it, for example, like the status. We have internal status in Oro. This is used for internal purposes, so you can expose it if somebody needs to know, but we do not add them in the post request, so you cannot like to set it through the API. So again, the documentation. And here also you can protect specific action with the ACL resource. So if for this specific action you would like to check some ACL resource, this is as we could configure it in any other YAML. The one I told you about the events, we have the form event subscriber, and this will be executed only for those forms in the API. So really, really useful. And the important thing that for each action, you have the fields where you can configure the field itself. Now, how does it work and how you can customize it? Soraya, I see the information that you cannot hear me correctly. Please let me know, guys, if now it's better. Okay, thank you. Thank you for pointing. All right, so the processors. We have custom processing for the API requests. So this, like we mentioned in the very beginning, there's a chain of the processors. And they might contain the business logic of data API. It may change any configuration of data, so you can do a lot in those processors once you understand how they work and in what orders they are being executed. The important thing here is that despite the fact that those processors are just the services tagged with the oro.api.processor, you can also add conditions to those tags, and this is very important thing. So you have action, groups, and classes, and also they have the priority. So here is how to create the processor. Actually, those can be very, very simple services. They must implement the processor interface. And you can see it have just the process. An important thing, it takes the context for the processor. The context is the thing that is shared for all the processors in the chain. So once you do something at the very beginning of the request, you can add it to the context and it will be still there when you add additional processor at the end of the request, so you can change something and modify the output, for example. So very simple service. You just need to implement processor interface and have the process method with the context interface argument. Now you have the service for it. So we point the class, and the important part is here. So as I told you, we have the tag, it must be there, but also we have some conditions. For example, action get, group normalize input, and the priority, which means that this processor will be executed in the normalized input group only for the get request. Okay, so if I request something with the get list type, the processor will not be executed. If the request with the get, it will be executed. Okay, so I can have different behavior for each request type. And another thing that you could add here to the condition is a class. So here are all the conditions. Without any condition, you will execute this always. You can check, for example, if you're authorized, right? You would like to always. Then for a specific action, then only for a specific action in a group. For a specific request type, we're also gonna cover this later on. Also, you can do the negation here, or you can do the connection for both of those, or alternative. But the important one is also you can have, of course, you can have few tags, and this one, the class. So this one will be executed in very specific need. So only for get list in the initialized group and only for the user class. So if I go and request something from the user entity, it will be get list, so I get many users, this one will be executed. Okay, so this is a chain of processors. There is already a lot of them defined for each request, but you can add the new ones or even modify the existing ones. Okay. And I think the example is just the same. Yeah. So I can, for example, set user profile entity. If somebody will be calling the user profile, I inject the security token storage inside the processor, and there I can use it and add it for example, to the context. So please remember the context is shared for all the processor in the chain. So context, as you can see, it will be action specific. So here I have the action, and for each action there is a one context, and also there is a main processor. So this is the entry point. It have the registry of all the processors for given action, and they will be executed. And now, how are those being executed? So first of all, for each action, we have different groups defined. So for example, I have get, and for the get, I have group initialize, resource check, normalize input, security check. Then I build query, I load the information, I check the security of the data, I normalize it, finalize, and normalize the results. Sounds like a lot. In every of those groups, there can be many processors, and the groups are always executed in this order from top to the bottom, and processors inside the group are always executed in the priority order. For each action here in the documentation, you have the full diagram. So this is where you start your request. Those are the processors, and they go on, right? So if there is an exception, you go straight to the normalized result. Otherwise, you go to the next group, execute all the processors in the group, and here you have the information what is the responsibility of each group. So this is really important to understand before you start to customize. So for example, if you need to add some computed field, so you don't need any additional query, any additional security check, you just want to add the field and compute its value, you probably would add it for the finalized group. Also, there is a quite good debug command for this. It's gonna be a long one. So here I have the information that the total number of processors is nearly 1,200. But first, I have the groups for each action. So on the left, I have the action. Then I have the groups and number of processors inside. So for example, we had a get. So in get, I can see I have initialized, resource check, and so on. The same list I had here. And also the total number of processor in all groups. So it's 78, but as you saw, those are very tiny services, most of the cases, and the API still is very good on the performance. If I would like to understand this more in details, I can execute the same command and then just provide the action that I would like to get more information about. So get. And now I have the full information for each group, for every processor in the group. So this is really long list. We had 78 there, as you remembered. But for most of those, I also have some description. So actually this is, yeah, now I can see it. So I can see in which group it is, and what is the priority of this processor. So thanks to this, if I need something really custom, I can think between which processors I need to inject some functionality, and I just register new processor in the specific group with the specific priority for this specific action, and I can modify the context between the processors that are already there defined. See, so here I have the conditions, here I have the processor, and some information about its responsibility. In most cases, for your entities, you will not need to do this, but also there probably will be some entity that your client will have very specific needs, and then you can modify it like this if modification from the API.yam will not be enough. It will be part of the practice and also the one I like. So I will demonstrate this you maybe also with some X debugging to show you what is the context content. Okay, so right now it's important to remember there is a comment to debug it, and also there is really a lot of information here in the documentation about the API customization. And so I told you about the processor groups already, so they are specific to each action. So for example, if you add some processor group that this is not part of this action, it will not work, of course. Then we also have X-include header, and this is the header that you should add to request some additional information. And of course, you can create custom includes, and then documentation, there is example how to do this. So here I have the header, and I have X-include total count. Actually, if you saw here in the REST API, I have no 8OS for the get one, but for the get list, as I remember, that was also total count, right? It makes sense. So you request the entities, and for example, there is really a lot of them. So you just got the first page. Here you have the pagination, right? But also you have the information, what is the total count? So you can, first of all, display pagination at your side, but also, understand what is the number of the entities you are looking for. And let me find it. Oh, it was somewhere here. I cannot see it right now. Where is it? Okay, I will take a look for this in a second. But also the idea, and this is used in many cases, if you would like to delete something, right? You delete with some specific condition, and you would like to know how many records you've deleted. So you can have the information request for delete count, for example. The important things, if you would like to add your X-include header, is to handle this in two cases. First of all, in the positive scenario, so you add the header, and at the very end, it will be added to your response. But also, if there will be any exception, you should add the processor to remove this header from the response, because this is bad practice, and this is not something you should do. That if you return the error because there was some, for example, mistake on your request envelope, and you return the error 500 plus total count or something, right? If you return error, you should not return any data. So it's important that if you added X-include header, you should also handle the exception, and if there is an exception, you should remove your header. You remove your information from the header. Also, the thing worth to mention, this API is different for the environment. So if I have the dev environment and there will be error, I will have the information about the error and the error message here. If I use this only in the production mode, I will just have the status code 500, for example, and I will have to look for the error in the logs, right? So how to add it? You can create a custom processor, get the headers from the context, and if there is a header, for example, like deleted count, you add some information. Okay, so you just need to think in which processor group you have the information about the things you've done with the query. right here, I have the results from the query, and I just add it to the header. So I have the header constant, and I just count the results, and then I add it only to the specific action in the specific group, right? So this is how you add some custom thing, and that's it. You added this x-include header just to this specific action. Now, a little bit more complex example how you can handle this in the API YAML. So here you can see I have the entity, I point to some documentation, I have the configuration for the fields and also for the filters. Depends on, is important because if this field is gonna be fetched, those additional fields also be available in the context, despite the fact you may not have them here in the configuration file. And also I have the sorters. And if I have more entities in this bundle, of course, I add additional entities here. Like, for example, I have the configuration for the leads. So in really many cases, this will be enough to customize your API. But if you have more specific needs, really going with the processors, you can customize it at any level you would like. And at the very end, if this is not enough for you, you can just create the custom endpoint, point to the controller, for example, and just do your action inside the controller in any way you would like. Also, about the documentation, there is a very good article how to add this custom controller, but also two use cases that we really use a lot. First of all, you can change the identity of the entity. For example, you have the order and you have some external order number, okay? And by default, the ID will be used for the identifier for the API. But you would like to change it, and for orders, you would like to use different column to be identifier. This is possible, just change the identifier. I think it was even hinted here for the fields, was it? Or for the entity? Yeah, identifier field names. And I can specify which are the field names for identifiers. In many cases, it will be enough, but let's think about, we have few integrations, and most of the integrations would like to use the ID, but only one would like to use a different field. And this is actually a little bit more complex because I have one API, and now for different client, I would like to configure it differently. And this is possible adding the custom request type, as I remember. It should be, yeah, custom API. So by default, I have a request type like REST or JSON, and I could define new request type, for example, ARP. And then for this request type, I can override some configurations, okay? So then our client would just send the information about the request type, and he will have differently configured ARP. And also this request type was possible to be used in the conditions of the processors. So I can even customize this for the request type and ask my client, hey, please use this custom request type, and then your order will be identified by the order number, not by the order ID, for example. Okay, so really useful examples. And enable custom API, just what I just said. The important, we also have the front store API. This is quite robust. This is already being focused a lot at this moment. It will be not covered right now, but you can access the sandbox from the front store of the application. So if I go here, let's open. And as I remember, it's API doc. And you have the sandbox from the front store, so you can see what entities. There is, of course, less of them because you should not access all of the entities as the front store client, but also you could create orders using the front store API if you would like to build, for example, headless application. And this is being developed all the time, really strongly focused. Also, it will be covered in a little bit more detail during the commerce webinar. Okay, guys, any questions and answers? Let's discuss them right now. Then I will show you the practice and the solution, and we will do this like 10 to 15 minutes break. So I can see there is also only one question. Marcos, can you explain us how tags work in the YAML? Okay, Marcos, so tags is like this symphony thing, and this is to categorize services, let's say. So I can tag a service, and then I either can use this tag to iterate over those services in some compiler pass, or also I can get the iterator of the services using the annotation services. It was like services YAML. It was tagged, right? Tagged. Okay, so right now I can tag some of the providers, for example, and I can build the registry of the providers using compiler pass, or in the services I can go get the iterator over all the services that were tagged with this. And inside my registry, I have this collection. And for example, we can use this for normalizers or for any other things that you can have many, like name providers. And then I iterate over, I check if this one supports my entity or not, and go to another and another. So tagged, I can group the services for specific needs. And also, as you saw here for the processors in the API, the tag can have some additional condition, and this is just for the API. And then this service will be loaded only in specific conditions are met. Okay, so this is when you could work with tags. Okay, let me check the Slack. And no, there is no question to Slack channel either. So let's talk about the practice. This one. It's rather simple one. So we should add a default API for the user naming type. You've already seen this in action because I switched to this branch right before I started showing the slides, started the presentation. We should add the filter and sorter by title. Optionally, we should set custom alias for the whole application, not for the API. I will show you the difference. And also I should create example of formatted name as a meta field and add it to get and get list requests. So first of all, to enable, very simple, I added the API YAML, I added my entity, and that's it. Then I should add the filter and sorter by title. So I have sorter, filter, fields, title, exclude false. That will be it. And okay, so this was added through the webinar. And also I've added this meta field, okay? So I've added it, but it have no value because I need to provide this value in some processor. So I have the API directory, and here I have the processors. I have two different ones for get and for the get list, and actually we could try to debug it. So I will just add some breakpoint here. I enable my xdebug. And let's go to the sandbox. And this was for the get. It will take a moment when the xdebug is enabled, but In a second, we should have it. Or actually, we could also do this in opposite way. So it's disable first, refresh it. Then let's find naming type. It was for the get. And then we can enable this. It's okay. And now let's try to do the request. Okay, it's here. So I can see it was called from the chain processor. It was calling execute processors with the context for each of the processors, and you can see the processors here. Okay, it should be. I can see the list of the processors, processor registry. And now my processor was called. And here I have the access to the context. I can check what's inside the context. I can modify the response header. I can check the filters, anything. And also I have the results. So if I go a little bit further, I can check the results. You can see I'm still having an array here, not an object yet. So I can add something to this array and then set the results. You can see I've added the name example. It was configured as meta field. Now I've added some value and continue. And here I have the meta name example. And this is how the service was tagged. So it was API processor, action get, group finalize for specific class, and with some priority. So if I would get request get for any other entity, this processor will not be used. And that's it. So guys, let's do this 10 minutes break, and 10 past, we're gonna continue with the integrations topic. Okay guys, I think we can continue. And right now we're gonna talk about the integrations. This is quite complex topic, so we're not going into very much detail, but still we should talk about the most important things to remember about the integrations. Also, please, if you have any questions, guys, post them. Questions are good. Discussion is something we really need so we can understand fully. If there is something that's not obvious for you, just type the question here on this or on the Slack, and we will discuss it. And also tomorrow we have a longer session planned. So what is the integration? It's just communication or some data sync with third-party application. Usually it will require some credentials and can be RPC, SOAP, or REST. In most cases nowadays it will be like REST. And if you think about the data sync integration, it's an import and export of entities. The only difference is the reader or the writer if you export, right? So you read from the API, but then you have the processor and you have the writer in the database. If you export, you read from database, you have the processor, and then you use the client or API client to write the information somewhere else to send it, okay? So it is actually the very similar process with just different endpoints. During the implementation, this is very important. Think about the application, about the integration, how complex is it, how important is the logging for this, so what level of logging you should use, and then find the balance between the cost and the performance. It's not always recommended to do the full integration if you just need to get one information on very specific conditions. So we're going to talk about the ways to integrate, and they are similar, but each of them have different pros and cons. So we can create the simple controller or even the CLI command with hard-coded configuration. We can create the controller or command with the configuration, the system configuration. We can do the proper implementation with the configuration at system configuration. And the last one, we can do the proper implementation with the configuration at the integration channel, okay? All of those have their needs and their purposes. I cannot say that one is just bad. Of course, it's less extendable, but also you can use it in some conditions. So the simplest one is just the controller or the command with the hard-coded configuration, right? So we got the client for the API, for example, so the ready client written by someone else, and we just add some controller action or command that uses this client. It have hard-coded, which is always bad rather, hard-coded credentials or the configuration, and that's it. So it's very easy to build and it's very quick to implement, but that's all the positive sides you have. But it's difficult to configure. It's not configurable at all. If you want to configure, you need to change this hard-coded configuration. It's not flexible. It's hard to support because if you would like to do something, you go to this controller and check it manually. And you can only have one instance, right? If this is controller action or a command. The configuration is hard-coded, so you cannot call it with different configuration to execute different, to connect to different endpoints, for example. Okay, so it's the simplest one, but it have obvious drawbacks. A little bit better is the same implementation, but you move the configuration to the system configuration. What you get, it's configurable, right? If the endpoints change or the credential change, you can go to the system configuration UI and change the credentials there or the endpoint there, and it will still work. Still, it's not flexible and hard to support, and still you can have only one instance. You can change the endpoint, you can configure this instance, but still it will be only one because you have one instance of global configuration. Then we can do the proper implementation. So you will see what are the classes needed and used in the integration in Oro with the configuration of the system configuration. It's configurable, it's flexible, and easy to build, easy to support. It is harder to build. As you can see, there is plenty of classes you need to understand and to use. It's slower implementation and still only one instance because it's configured at the system configuration. And the last one, most flexible, is the proper implementation with the configuration at the integration channel. So you define some integration, you have the client, you have the transport and everything, but the configuration is added at the moment when you add this configuration to the system. So you can add many instances of this specific integration with different configurations. So for example, you can have configuration with some third-party system and connect to two different endpoints, or for example, two different credentials, okay? So it's configurable, it's flexible, easy to support, and important thing, you can have multiple instances. It is hard to build, well, hard, it just takes time. It's slower to implement and it's slower to just build it. First of all, where do we have the integration? Let's check the application now. So you go here to the system and it's the integrations. By the way, I moved to the recent branch, so I will have those changes already in my code. So I have some integrations here with the demo data, like payment terms, the Zendesk flat rate, and also if I would like to create the integration, there is already few out of the box in Oro. You can get more by installing the extension either from the external bundles or from Oro Marketplace, and you will have another integrations. So if I choose the integration, for example, we're going to talk about the Zendesk soon, you will see that here I provide the configuration, right? So I can have few Zendesk integrations at the same moment with different configurations each. And also, what configurations are required for each integration, you specify yourself in the entity. Then you have connectors, like each connector is different import-export. And then you can have status. Also, if your integration is two-way, you can enable two-way sync. We're going to talk about it in a second. And then if you have two-way sync, you should define who is the winning side. So if there is a conflict on information, is the information from Oro more important on the one from the third-party API? Okay, so it's really up to your application logic. So what can we configure as sources? We saw those in the examples. So it can be its system configuration. First of all, it's one on the global level, or can be one per each scoped entity. Now remember, you have the user website, but usually the configuration you would add to the global level, and then if you would change it, you will change it globally. The second one is what you just saw, is in the integration channels. I can create any number of instances of this specific integration, each with different configuration. And also, actually, you will not see it here because I do not have the credentials, but if I would go to some integration, yeah, probably it will not work, but I can schedule sync. So I can, of course, it will be scheduled with cron, but I can just, force it. And also here, you will have the logs. If you create your own integration, you need to take care about adding those logs. But you have easy access to see the statuses, you see the responses or whatever you would like to display here. So this is pretty nice because you don't have to go to web server logs to check something. You can get the information, for example, that the API is not responding or something here in the integrations view, and also force the sync. Also, as you can see, for each integration, I can enable different connectors. So for example, from this given endpoint, I would like to synchronize only users, but for the different one, I would like to get all users, tickets, and the comments. So the sync. If we have the integration that is data sync, it is actually executing the import and export via the connector. So each connector is executing different import-export job. It's done asynchronous, so this is really important point about the integration. Usually you don't want to do them synchronously because they may take some time. What is important, this is asynchronous on the single integration level. So we have many integrations that will be run in parallel, but if I have one integration with many connectors, they will be executed in a single process one after another. And this is mostly because usually I need to run those in specific order. So first, I'll need to synchronize users. Then I can synchronize tickets because I will have already users for those tickets. And at the very end, I can synchronize comments so I can assign them to the tickets that are already synchronized. So by default, it will just go inside one process, one after a connector after another. You will see the request history there in the log when I showed you. And integrations are being executed with this Oro cron integration sync. You don't need to add it to the cron manually. It will be added because it's in Oro cron and implements cron interface. So as you remember, cron in Oro is executed every minute. It checks what cron commands should be executed and it executes them. By default, integration sync runs automatically every 5 minutes. So every 5 minutes, he checks the integrations, execute them, and each integration can also have its own configuration if it should be executed at this moment or not. For example, check some last synchronization date or something like this. So there are two types. The first one is a direct sync. So we just pull the information from some third-party service, right? There is a inventory management, for example, and once a day we pull the information about the inventory. So this is like importing information, but instead of CSV file, we have the API endpoint, So for this, we are using sync processors. And I will be showing you this on the Zendesk example using. So we have the sync processor. This sync processor gets all the connectors from this integration and one after another execute them. So for example, in the Zendesk bundle, let's open any. So here I have the batch jobs. So as you can see, I have different job for each of the connectors. So I have Zendesk user import. As you remember, for the import export, we already had them defined. Here, usually we need to define them because they can use different endpoints. So I have Zendesk user import. It's very similar to what we did on the import export, but in the steps, I have the reader, and here I point to the connector. Okay, so the reader is using Zendesk user connector. For the ticket connector, is a ticket connector. And for the comment, I have the comment connector. And also I have some jobs for the export because we have two-way sync for the Zendesk, but about sending information back to API, we're gonna talk about in a second. So this is the reader, this is the connector for the user. I can go to this connector, and here you will set the information that the connector knows which job should be executed. So he knows about the import job he's supposed to execute. So there is a sync connector. He gets all the connectors for this specific integration, and one after another executes the import for this connector. So he reads the information. Here, as you can see, get connector source. This is very important method. This is the method that is getting the entities for the third party. Usually, it will know about the transport layer. So, for example, REST client, and it will use specific method. So here you can see this user connector to get users from API is executing get user from this transport layer, and it's sending the last sync date to not get all the users, but for example, only the users modified after this sync date. And the transport is the class responsible for knowing how to get the information from the API. Okay, so this is your client, API client. The connector doesn't need to know about it. It just needs to know which method of this client to execute, and then it will proceed like with the import of the data. So this connector returns rows one at a time, the processor processes them, and the writer writes them to the database. Okay, so it's really important that you see that this is similar to import-export in any matter. And then a little bit different is a reverse sync, okay? Because usually you don't want to send the information with some schedule. Usually you want to send the information after some action. So for example, you can create a listener for the entity, and after persist or after updating entity, you can sync, okay? So also example is there for the Zendesk. We should get the event listener, and for example, there is a case entity listener. So for the cases, he's listening to some event like before save, this custom event, and then if the conditions are met and if the integration is enabled, he will the sync comments, for example. So get the sync manager, sync comment. Here we check if the two-way sync is enabled, and if yes, we will schedule the synchronization, okay? So this is when we send the information. It will, again, use the batch job. So we had those batch jobs here also for export. We have the comment export here. Oh, excuse me. It's reading the information from the database actually, or just delete also the entity we modified. And this is your writer, and then you execute the process and send it through the transport to the API. So important thing to understand is that the transport is the layer that knows about the API, and this is the only place where the API specifics should be in your logic. So if you would like to build the integration, how can you start? First of all, you need to create the channel type, and this is the thing that you had in the dropdown. So when I was creating, all of those are the channel types. Then you need to specify the transport, and for the transport you have two classes. The settings entity, so the class that we're gonna hold this information specific to this integration, to this transport, and the form type. So if you can see, whenever I change this channel here, I will have different form displayed. So each integration, needs different configuration, right? For example, payment terms, actually, it's a fake integration. It doesn't integrate with any external system, but it follows all the integration logic. So it's displayed here, and it can be used as a payment method, for example. And then we have the connectors, one at least, but for example, here in the Zendesk, you saw there is 3 different connectors. So first of all, we have the channel type. It represents the integration type. So it can be Zendesk, can be UPS or some payment method. It contains the label and the icon, just to display them there in this dropdown. And it's tagged with the Oro integration channel. Something very simple. For the Zendesk, it would like this. We can implement the interfaces, channel interface, and the icon aware integration interface. And then there is only 2 methods, get label and get icon. Okay, we also have the type, and this type is used in the services. So let's open this channel type in the IDE. As you can see, I have it tagged with this specific type here. So here I have the type Zendesk for the tag. Then we have the transport. This is really important class because it's the communication gateway. So transport knows how to communicate with the API. So it should get the reference to the settings, both entity and the form type. It may contain the methods, like sometimes it can be even the ready clients that you're gonna use, but usually you just want some proxy. It's tagged with Oro integration transport. Again, let's open this actually in the IDE. Yeah, this one. No, not this one. This one. So we have the transport. As you can see, it knows how to get user, how to get tickets, how to get comments, but also how to create users and tickets. So this is like when sending the information. So this knows the logic of the endpoint. But also it gets the label. It knows which form type should be used for the settings. Okay, so which form should be displayed whenever I go to this integration and pick the specific channel. So my transport knows about it, and which entity it's used for the settings. Okay, so I need to create those 2 things for the integration. I need this entity for the settings and the form type for those to represent them on the front store. And you're gonna see this also in a second. There we go. So now we have the transport settings entity. And here, one very important thing, we are using single table inheritance. If you have not worked with this, you can check the docs, but the idea is that some of the entities are extending the base transport entity and adds its own fields. But all of those fields are kept in the same table. So let's actually see this, how it works. have Zendesk transport entity. And first of all, this entity extends the transport one. So this is one, it's from the integration, and it is, as I remember, inheritance type single table, okay? And also there is a discriminator column, which is type. So by type, it can have different. So this transport will be extended by all the entities for all the different integrations. But if you, for example, have instance of Zendesk entity transport, you will only have access to the properties of these specific entities plus the parent one. So you will not have access to any other entities that are extending this transport. Okay, so the transport have the information about the ID and the channel. And then for your integration, you're adding additional columns. Just please remember they are sharing the same table. So you should prefix them with the integration prefix. For example, CRM Zendesk. So then if I open the table, okay, sorry. As you can see, I have the ID and the type, and then I have the columns for all different integrations. But when I create an object for my specific Zendesk REST transport, I will not have access to all those columns that belongs to other integrations, only to the ID, type, and my columns, which are here prefixed with the Oro CRM Zendesk. Okay, so I have some properties. And for this entity, I need to create a migration. As for any other entity, I need to create those columns. Getters and setters, and also there is one method, get settings back, and this one is used by the transport. So I need to return all the settings with the keys, and it points to the getters of the properties. Okay, so I need to create this entity, and please remember it's using this single table inheritance. So I just need to add those columns to the Oro integration transport table. Once I have this, I should create a type, so the form that's gonna represent these settings. So we have form type. It works with the settings entity and describes how the settings are rendered when you select the specific integration channel. And you can see them at the edit a create page. For Zendesk, it's very simple form actually, and it's here. Okay, so I have the build form. I add the components for each of the properties I had in my entity. So it was URL, email, token, and Zendesk user email. And that's it. Okay, of course I set the data class in defaults and get the name and the block prefix. So I created the entity to represent the settings, to store them, and I create the form type, and transport knows about both of those classes. So thanks to this, whenever I pick the transport from the dropdown, the correct form is being displayed. And once I store this information, it will create new row in Oro integration transport table, and only, of course, fill the columns for this specific integration. So for example, for Zendesk, as you see, all of those are null or zeros. And here it will be Oro CRM Zendesk. And here I have the values for my specific integration. So whenever I create object of this REST transport, Zendesk REST transport entity, I will have only access to those specific properties that belong to this entity and the parent one. Okay? Okay, let's continue. Then we have the connectors, and this is the import definition, right? So this is what defines what should be imported. So for each entity we would like to synchronize, we should create a different connector. So if you synchronize with some external commerce system, we should get users orders, order line items separately usually. So each entity is a different connector. If there is a one-way connector, it's only importing the the records. If this is two-way, it's both import and export. We need to tag it properly. And the example for the Zendesk is a ticket connector. This, as you remember, was to-sync. So we implement two-way sync connector interface. And here we have some constants. First of all, for which entity, okay? What is the name of the import and export jobs that this connector should execute? And the type. Okay, so the type is used also for the service. So first of all, get connector source. This is the method that needs to be called like this. And this know how to get entities from the transport. Okay? And rest of all, just the methods that are required by the interface. So we can get label for this transport, for this connector, excuse me, and this was displayed here in the integration. And then we have the class, the import name, the export name, and the type. Excuse me, it's here. Okay, so as you can see, there is quite few classes you need to add, but thanks to this, if you just follow the procedure, you will have it as a full integration. You can configure it, you can create many instances, you can see the logs, and you can force the sync. You know, there's quite a few additional things you can do with it. So this is how the schema should look like. You have one channel type, so for example, Zendesk. Then you have the transport, so the class that knows the logic how to communicate with the endpoint. And this transport needs two classes to work: settings entity and settings form type. So you display form type whenever you select this channel when you create new integration, and then you store it in the settings entity in this single inheritance table. And then you can have many connectors. It can be one or few. They will be executed in order, not parallelly. And each of those connectors should get different entity from the endpoint. What are the integration types? In many cases, in most cases, it will be data-based. Okay, so import and export of entities using connectors, and is a synchronization. But also you can have some operation-based, and then you can create it with your own interfaces, because there will be no connectors, no synchronization. You will just execute some call on the action in the system. For example, you just, whenever you store something, you just call some actions. And sometimes you can have combined. So you fetch the orders, but also every time the order is changed, you can send some information to the API. Okay, so integrations really cannot be easily defined. For every service or every application, you can have many, really. Usually there is quite a few. And it can be different types, it can be different endpoints, and really different requirements. Sometimes you need to synchronize live. In this case, we strongly recommend to introduce some caching, and so your user won't have to wait for the response, but not always this is possible. For example, you can get pricing, live pricing. This is something really were requested quite a few times. Then, what are the possible issues? First of all, you can have some performance. This is exactly as for the import-export. If there is a lot of records, it's using ORM, it can be slower. By default, there is no failure tolerance for the third-party system. So if you would need to add some tolerance, for example, what to do where is a timeout, or when you send the wrong request, or there is a wrong response, you should handle this by yourself in your integration. Okay, so this is important. By default, there is not handling on the global level. And some best practices. If there is only one instance of the integration required, it's okay to store the credentials at the system configuration. Just do not forget about using encryption, right? So this should not be plain text field. Well, it cannot be. Then always should isolate the work with the API at the separate layer, okay? So The transport, and I know I repeated a few times already, is the only place that should knows about the specific of the endpoint. And then your connector will just call the method of the transport to get the information or to send the information. And as always, you should inject the logger and really log all the critical places. So you should log the information that some API was called. You should add some notices when you create the entity, and of course do some error processings. Documentations, and I think there is also a doc how to create a integration step by step. It's just for you, we're not gonna follow this right now. And yeah, guys, we can do the question answered now, or I can show you the practice and do the question and answers after this one. How do you prefer? I see that actually, yeah, there is no question at this moment. So I will show you the practice, and actually this practice is at some point fake because it's not real integration. Creating real integration takes really quite a lot of time, so we cannot do it right now, but I will show you how to start, what are the practices to go on to create an integration. And then I will answer any questions in the chat and we'll do the break. So let me show the practice. And let me check if I switch to the correct branch. Yeah, okay. So we should add the integration channel and the transport settings. And this fake integration we're gonna create would be reading some information from the URL. At this URL, we're gonna host JSON file. So our response from the API will be JSON file. And then the connector, and this is where we kind of cheat a little bit, will be reading the information from this JSON file and changing the database, okay, modifying. So this is where it's not real. We not create a real connector with the real implementation, and also there will be no transport. But first of all, how do we start? Let me close this. Okay. So we have the integration directory. It's up to you if you want to put everything related to integration in one directory, or just create the connector directories straightly in the bundle itself. So first we should create the transport. And this transport, excuse me, we start from the channel. So channel type can be naming type. We have some label and the icon. If you want to have this icon, of course, we should add it to the resources, public, image, for example, and the naming integration icon, and then install assets. So it will be moved to the bundles and we have the access to it. Okay. Also here in the public, just for this practice, we added 2 JSON files. And again, if the assets will be installed, you will have those under the URL that is specified here on the slides at the very bottom. So you can have URL to this JSON. We can provide it in the integration, and it will be our fake response from the transport layer, so from the endpoint. So we created the channel. We need to tag it, so our integration channel with the type. That's it. Then, as it's specified in the task, we should create a migration, and our only property for the integration is going to be a URL. So we need to extend this table that was using single table inheritance and add the column for keeping our setting. So we go to the migrations, create directory 1.2. In the app, we get the table, and we are adding column. Please remember the prefix. If you would call it just URL, you will not know for, if you take a look at the table, you will not know for which integration this is being used. Okay, and also probably most of the integration will have some URLs. So we create username URL, and probably I already executed to remember the migration, so it should be here at the end. I have it. Okay, so I created the migration. I need to create entity for this. So username integration settings. You need to extend the base transport. And here I have the URL column. This is the only column. And I have to also have the settings. This is like the parameter back, and I need to return them. So I have get settings back, and I'm returning the parameter back only with my one property, which is URL. I created a constant for this to have URL here, so I can reuse it in some other places. Okay, so I have channel, I created the migration, and I have the entity for this settings. Now I need to create the form type. Very simple one, always, not always, but in most cases we extend the abstract type, and in the build form I only add component for this one field, which is URL, and I set to data class to the entity I just created for those settings. So what's left is to create the transport itself. So I have naming type transport. I implement some transport interface. I injected doctrine helper and the logger because we have this fake, right, integration. We do not have any logic about the endpoint here. And what is important, I need to set the setting form and the setting class. Okay, so those two are very important. This part is like I said, not the real implementation, because usually transport will be getting the records from the third point. Once I have this, I should be able to go to, of course, I need to execute the migrations. I should be able to go to the front store, to the management console. And here I will have username integration. Whenever I click it, I should see the form for my integration. So the name is here because it belongs to the transport entity, and source URL is here because I've added this one setting and I've added this field to the form for this specific integration I created. Okay, so here I would post the URL. I'm not sure if I installed properly, but it should be like this. And then I can get link from the presentation. Okay, no, I haven't installed the assets yet. Okay, so once you install the assets, you should see your JSONs there. You can post the URL. It will be stored for these transport settings. And then whenever you execute, it will execute the connectors. Right now, as I told you, we did some fake. And if you're gonna check the repository, there is information. This is not how you should proceed usually. This is just to demonstrate you. So it will be getting import names, importing the names from this JSON file. And here we created some logic how to handle if this should import or skip. Please remember, usually you will just use the connector to execute some import-export job. So this is just for demonstration purposes. Okay, so this is where it's not like the real implementation. Otherwise, the channel, the transport entity, and the form, this is what you should always do. And okay, please, if you have a moment, always switch to this branch and try to take a look at this solution by yourself. And tomorrow we can discuss it if you have like really something that needs explanation. For now, I see there's only one question, and there is Adrian. If you need to add a button in product view only when enable integration, how you can do this? You can do this with operations, Adrian. It's not a very short answer, so please post it to the Slack and I will give you some example and I will continue the discussion there. Okay, right now, let's do this 10-minute break and we're gonna talk about the message queue and actually put all of this together and see how it works, okay? So 10-minute break, guys. Okay, let's continue. And Adrian, thank you for posting the question in the chat. So you can do this in many ways. You can add this button in Tweak and create some Tweak extension that would check if the integration is enabled or not. But also you could add this button using something called operations. We're gonna talk about the operation processes and actions tomorrow when we're gonna talk about the workflows. But to put it simply, the operation, for example, was used to generate this remove button for the data grids, but also it can be added to the view page buttons. So there is a doc of the operations, so just you can type Oro platform operations, and here you can specify for which entity it should be added, and for each route, for example. So you can define that this operation will be added only to specific route. And here you have a bunch of other options we don't need to cover right now. And then you have 4 properties: pre-actions, preconditions, conditions, and actions. And what you would need preconditions or conditions, depends on your need. And I would create some service that would be returning the true-false information if the integration is enabled or not, because you can have many integrations and probably you are thinking about one very specific one. And here in conditions, you can call any actions, not just one. You can call many different actions, also call specific service method. And for example, only if this method will be returning true, you will display this button. So actually you would use preconditions. So only if this method is true, you can display the button. And then in the actions, if somebody click the button, what should happen? So this is pretty nice functionality, how to create new functionalities using the blocks that already exist in the system, which are called actions and conditions. And we're gonna cover those tomorrow. Okay, and Christian also had one more question. You mentioned encrypting integration credentials. Is there a built-in way to encrypt DB columns? You can encrypt this using the form components. Let me just take a brief look for this. I think there was one for the Zendesk too. Okay, no, this one was using token. I will take a look. As I remember, there is a form component. You can just use it, and it's encrypted using the secret for your application. So this is pretty safe. And yeah, please, Christian, post this question to the Slack, and I will also add the answer there with the link to the component that we use. Okay, so guys, the last topic for today is the message queue. It's not the long one, but it is very important because you're gonna use this message queue in many places in Oro, and it's already being used in many places in Oro. So let me just find the slides. We can close all of those. Okay, so there we go, message queue. So this is just a queue with some messages. Okay, so by default, we have a message queue. In community edition, it will be in database. In enterprise edition, you can use database, but in production, you will probably always use the rabbit. And it's there to do some asynchronous processing. Okay, so there is a many actions that your user doesn't need exactly when he click the button. Okay, so for example, if you want to edit some entity, sure, he wants to store the changes and the changes should be there. But probably he don't need to see the changes history to be generated on the fly. He can wait a moment. So for example, persisting and creating the data audit can be done asynchronously. If you want to send big number of emails, you don't want to do this synchronously, you probably want to do this asynchronously. The same goes for the report. If the report is 10 records or 4, as you seen yesterday, in just a moment and you have the results. But in the production, it can be hundreds of thousands records. And if you want to run this export, you want to be done somewhere in the background, and then you just want to be notified about the results, right? Or you want to be emailed with the results. So in many cases, you just want to put something in the message queue. First of all, your user doesn't have to wait, and also message queue is not stopping the application, so the operations there can be a little bit less focused on the performance, okay? So it's an important thing. As we said on the very first day, message queue is a component built by Oro. So this is very abstract. It doesn't have any dependencies to the Oro bundles, and you can reuse it in other projects. And then we have used this component in Oro message queue bundle. Again, quite good documentation in the bundle itself and also in the doc portal. So how to start Supervisor, how to work with the exchanges, with the prefixes, idea how the message queue abstraction work, and some flow. We're gonna see flow in different places in a moment. So if you need to get some details, also how it works for the tests, because for example, for VHATs, you have the message queue executed also. So quite a lot of information, and also something about the state job. So what to do if for some reason some job in the message queue is not being terminated. Demonstration I showed you actually on the first day. So if I persist some changes, so let's go to the admin. As you will see, I will not have my consumer running. And if I do some changes for the contact, or for example, export the context, right? I click export, it said that it started. I can open my mail catcher and wait for the email, but actually I will not get it because my message queue is not running. Okay, so now I need to consume the messages. You can see I had some different messages waiting, and that sent me some emails. And also in the moment he will execute the export for me, and I have the information that the export was successful. So the user just clicks the button and he waits. By the way, I haven't told you yesterday, if for some reason you didn't receive the email, you can find the records in the var directory import export, and here you have the export files created like this. Okay, so this is example that when something works asynchronously, so user doesn't have to wait, it is executed by the consumer, so it's actually faster because there is not just one thread, but can be many consumers for each job, and that's it. Okay, let's stop it for now and continue. So the message flow is very simple. Application produce the message, so we just send the message with the producer to the table or to Rabbit. And then there are consumers. So consumer asks if there is any message to handle. He gets the message. He checks the topic of the message. He searches for any processor that is handling this topic. If there is many, he creates a copy for each of the processor. Okay, so if there are many processors handling one message, the message will be reproduced for each processor, and it will proceed with the execution. Sending a message is trivial. You need to create a topic and some body, and then you can use message producer to send the message. I will show you this in the IDE. I will just check to the new next branch. Was it 8? No. 7 probably. Oh. Okay, this is, sorry, I forgot the number. Yeah, 9. I need to remove the changes first. Okay, and I have it. So if, for example, I would like to do something when the entity changes, I would create the event listener for this entity. I would inject the message producer to this listener. And then in post-persist and pre-update, for example, I can produce the message. So I have message producer send. Then I have some topics. Our recommendation, this is what we follow for all the topics. We create a topics class in the bundle. And these topics have just the constants for each topic and the information, what is this topic message for. Okay, so here we created async directory. Inside we have topics, and I have generated the example. The idea we'll be building right now that we have our user naming, and the example was generated on the fly, right? Here we would like to change. We create the example column, and every time somebody creates user naming or modify user naming, there should be message sent to the message queue to regenerate example. Okay, just a functionality to demonstrate the message. So my listener is sending the topic, and the very important thing, I should not send the naming type entity here. In the message body, you send the least information you have to processor to proceed. So I will just send the ID, and then the processor should get the entity from the database and handle it. I should not send the entity itself here. Only the minimum information required to proceed in the processor with the functionality. Okay, and that's it. So I send the message somewhere, and application doesn't care about this message anymore at this moment. So actually, let's open the message queue. It was consumed. I don't have any messages here. And now let's modify username. As you remember, we did not create an update or create methods in CRUD, but we created import export, or we enabled API. So in both of those places, we can modify our entity. So let's go to API. Again, we switch branches, so it will regenerate the cache. It will take a moment. Let me just check. Yeah. So let's get one. And then we can use this data to modify it. Oh, yeah. Oh yeah, I think I should copy the whole. Yeah, sorry, I missed the braces. Yeah, just like this, and remove the suffix. There we go. We modified it. Okay, we see the response that it was modified, and Actually, the listener should produce the message for us. Let's check. Okay, it did not. Let me check why. Ah, yep, my mistake. So I was tracking the changes for the format. Okay, the format was modified. Yeah, let's put the listen breakpoint here and let's debug it. Okay. Right, we stop in here. This is our example processor. All right, that's weird. Let's do the one thing. Let's create the whole cache and check this again. After switching the branches, I haven't done this. We'll put it like this, and then just refresh it. Yeah, I disabled text. It's generating the whole doc again, so it takes a moment. We should be able to get it right now. So again, let's get envelope. Whoa. Okay, that's my mistake. In this bundle, there are also the migrations, so I should execute whole update. I just wanted to save some time, but actually, this is how it gets to. So if I would just run the update, it will execute everything for me, and we will just return to this in a second. So in console, okay, it will do here. It will run the migrations, and we'll return to this in a second. Let's continue with the presentation. Sorry about this, guys. So once we have the producer produce the message, we need some consumers to process the message, okay? And for this, we need the processor because this is the class that is handling the specific topic. And processor implements the message processor interface. And in most of the cases, we are using topic subscriber interface. Then the processor gets the body of the message, needs to validate the body. So be sure that you have every required field in the message to proceed, and then process the data and return one of the statuses. So acknowledge, reject, and requeue. If there is some critical exception, automatically it will be catched at top and requeue the message. So let's see the example of those processor. So we have the processor for this practice. We implement both of those interfaces. The first one needs the process method to be implemented. The second one needs the get subscribed topics. So one processor can listen to a few topics, okay, and proceed different from the topics. So get subscribed topics, we return the array, and we use the constant from this topic class. Then the consumer reads the message from the message queue, it finds the processor. If there is many, it duplicates or multiplies the message, and then each processor just process it. First of all, we decode the body of the message. We validate. For example, here we send the ID, so we check if the ID is there. If no, we just reject it. Of course, we could add here some logging. For example, message incorrect, ID is missing, right? And then we have the logic. For example, we are fetching the naming type, so we are not sending this in the body, we will just send the ID, and here we can fetch the entity and generate the example, flash, and return acknowledged. Let's check the console. Yeah, remove the cache before it's run again. See, I had some issue with the cache. As I told you, always remove the cache before running the update. So that's it. The producing, as you see, is just calling the producer, sending a topic with some message body. And as you can see, consumption is also very simple. So right now we talk only about the simple messages. So something was done on the operation, we send the message, we consume, and there is no trace or no progress for this to be monitored, right? If we need some progress to be monitored, we should create a job for this. And the job can be unique. For example, if we want only one instance of this specific process to be done at the same time, for example, importing can be a unique job, right? I don't want to import two different files at the same time. Excuse me just a moment. Okay, I'm back. I don't want to import from two data sources at the same time because I may have some conflicts. So for this, I will run the job that is unique. So there is only one instance of this job to be running. And to check this, there is a table or a message queue job unique. And whenever I create a unique job, its name is added to this table. And it's removed when I finish the job. Okay, so as long as there is one, if I send new message to execute the import, for example, he will try to create a new unique job for this, and he will fail because there is already one in the message queue job unique. So this is important. You need to think if you want this to be possible to do this in parallel, or you want to just one instance of this specific job at the time. And for this, you have run unique. I will show you this in very detail with the Xdebug at the end of this topic. Right now, for example, integration processor is using the job unique. Okay, so we have job runner, run unique. We have the job name, so this is the thing that is unique. And we have some callbacks, so what should be done inside of this job, okay? So what are the jobs? Jobs is like the container, so there is just a container, abstract container that something is happening, and there is a message that is running, and we can, thanks to this, create the child jobs, for example, separate things like in import-export batches would be child jobs. So when I create an export, I create a root job, then I create the chunks. For each chunk, I will create a child job. So those child jobs can be executed in parallel. And those child jobs, after execution is done, they will set the status of it. And thanks to this, I will be able to monitor the progress of the export. So the progress is the number of the child jobs finished versus the total number of child jobs, okay? And if I have the jobs, I can also monitor this. So I can go to the application, and here I have the jobs. So if I just send message and I process the message, there is no tracing about this in the system. If I create this with the job, I will have a log here, and if this job has some child jobs, I can go in and see the chunks, okay? So I can see each chunk, and actually when this export was running, this progress bar here was changing, okay? Because every child job was marked as success, and then the progress bar was processing. Actually, yeah, we finished the migration, so please let's check again with this update. Again, we try to fetch, it worked now. Copy this, and we'll try to post it, patch it, excuse me. And we don't want to send meta field and example, and we just prefix and the first, okay? Try. It was executed properly. And now let's check the message queue. There is a message. So it was produced by our listener. And if you take a look, the body only have the information about the ID. And here in the properties, as I remember, we will have the topic. Okay, so this is very simple message. Queue consumer gets this message, finds the topic, finds the processor for this topic, and then the processor, and actually let's check this. So if we put the breakpoint here, I can enable Xdebug. Then I just need to add this information to start debugging from the console. So export the server name and the ID key. And let's consume the queue. And there we are. We are stopped on the process. So the processor got the message. In the message, as you can see, we have the body. And we have the ID, so it's correct. And then we just process the message. Very simple. We also have the information if this was already redelivered or not. So if there will be some exception, we would return the queue status, and then this message will be redelivered true. And yeah, let's continue. That's it. Yeah, our message processor modified the entity, but actually only changed the example. So format was not changed, and it will not send the message again. Otherwise, we could get in this circular reference. And our message will produce another message, and so on indefinitely. Okay, let's go back to the jobs. So I can create a job. And this job can just have the message and then be processed by itself, but also can create another jobs. Child job, delayed jobs is just a different name. So for example, for the import export, for each chunk, I will create delayed job. And this is very important. For each job, of course, I will send a message that will process this job. And inside the processor, whenever I'm working with the delayed jobs, I need to run delayed job or run unique. So I need to know that after this message is executed, after this message is handled, the job status should be changed. Otherwise, I will, perform the functionality, perform what was requested, but I will not change the child status. So the root job will never be terminated, never be finalized. Okay, so this is what you need to think about. And let's see the example. Oh, this is actually here. So I can create the delayed job. I create some name for this. And usually this is just the name of the topic and some ID and the type, because if I have chunk, it will be chunk ID. And inside, I produce a message to handle this job. Okay, so if I think about the export, there will be one message sent. Then the first processor will create the unique job for this, get all the records, divide to chunks, and for each chunk, create delayed job with the message to process this job. And then each of those delayed jobs, child jobs, can be processed in parallel, and they will report the status. And once those are executed, the child job, the root job will also be closed. I will show this in the very details just in a second with Xdebug. So the message consumer is just a process. So it's message queue consume, and we can set the verbosity. So as you saw, I was using -3Vs. So like this, so it's very verbose, and even when the process is idle, I have the information about the memory usage and about the select that is being executed to check if there are any interruption or any messages to consume. I can of course use less verbose mode. And then, very important in production, you have the limitations. And usually you at least want to use time limit and the memory limit. So memory limit must have, so if there is any memory leak in your consumer, it will not take all the system memory. So it should be killed after exceeding this memory limit. And then on production, we are using Supervisor to restart this process. I think there is a configuration for Supervisor here. Okay, so you defined what command should be executed, and most important, how many processes should be executed, if should be auto start, auto restart, and so on. So on production, you always want your jobs to be restarted because they will be interrupted. They can be interrupted because they will exceed the limits, but also they can be interrupted by some critical exception. So you can have multiple processes. In Rabbit, you have 2, 4, but actually on production, sometimes you have 30. It really depends on your application and depends what you are doing now. You can increase this number, for example, if you're doing some initial import and then reduce later on, right? So you need to scale it. And this is why Rabbit is so awesome. We also have consumer heartbeat extension, and this is sometimes probably when if you installed Oro already and you were going to the backend, there you had this red bar saying the application is not configured properly, please contact your administrator. This means that there are no consumers running. So this is displayed to the backend user to notify him that something may not be available, right? For example, data audit will not be generated or exports will not be processed, okay? And this is checked twice. First of all, there is a cron that checks if there are consumers and they're responding. And also whenever a user log in, there is a check sent and information is displayed to the customer, to the user, if there is something wrong and there are no consumers running. If you ever need to check very details how it works, you can go to this doc. How you can debug it. First of all, of course, you need debug. Message sending is simple. You can put the breakpoint in the listener and then just modify the entity. As you can see, if you don't have the CRUD, you can do this with API Sandbox, or you could just import this entity and do some changes. And then you should be stopped in this listener and you can check if the message is being produced correctly. Send product. Message processing is similar, but you need to enable this remote debugging from the console. So you need to go to the console and add this server name and IDE, okay? And really useful, you're gonna need this whenever you wanna work with the message queue. Otherwise, debugging message queue is really not simple. How you can extend. So you can create the consumption extension. So you can do something very special whenever you consume the messages. And also, there is few times when you need to clear the message and stop the consumers. For example, whenever you clear cache, you want to stop all the consumers, and this is already done automatically. So if I have consumer running, let's do this. I can run my consumer. All right, without Xdebug. I run my consumer right now, and I would go to the backend of the application and change some configuration. In such case, I really would like to stop the consumers because they are running they are using the cache. So they may be running with different configurations that I have in my configuration. So they might be producing the wrong results, for example. So I will go to system configuration and change anything. By the way, here I can enable or disable API. I forgot to mention, excuse me. And product. Something like this. The consuming was interrupted because the cache was changed. Okay, so it killed all the consumer. On production, the supervisor will run it again, but they will rebuild the cache and they will be working with the same state as the application. So this is a very important thing. If I need to do anything else in this particular step, I can use the clear interface and create extension using this one. And the last one is a job extension if I want to extend something what's happening with the job. I really don't have the many use cases for this because in most of the services I work with, we didn't have to do anything extra to the message queue. We were just using this, we were creating new processors a lot and then new messages, of course, new topics, but didn't really have to extend it that much. Some best practices. For the production, you always want to add limitation to the message queue consumer production, to the message queue consumers. So at least the memory limit, sometimes also the time limit, not so often the limit of the messages. And you always want to use message queue to every data that you don't need to calculate immediately. Sending some emails, some mailing, reports, exports, or data audit is perfect example what should be done with the message queue. For example, if you want to calculate some sales statistics after the order is created, usually you don't need this immediately. You can send information to the message queue would get the order you just created and update all the sales information. The message processor can be a little bit slower because nobody is waiting for this at this time, but still you should think about and care about the performance. And you should always remember that whatever is in message queue can be done in the parallel. You cannot, think, okay, this will be executed first, this will be executed later, because maybe one consumer will be busy with something else and the message you sent as a second would be consumed third. So you always need to think about the logs and the race condition. If you created some custom functionality with message queue, locally it's also good to test it with few consumers. So for the development time, you can run it once and debug and everything, but then you should test it with the production similar environment and consume it with many consumers. Before we go to the questions answers, I will show you the process with Xdebug. And also I will show you the doc. And this is the diagrams I told you. You can see them in the component message queue. So how the simple message flow works. You produce it. After some time is passed, because you can also set the delay for the message. The message queue is the message is put to the queue. Then it waits depending on the number of consumer and the number of messages in the queue. If there was expire time set and this time expired, the message can be removed from the queue, but usually it will be taken by the consumer. The consumer executes the processor. If there is many processor, it will create the copy for each, and then it can return the requeue if the exception was thrown, and it can return the acknowledged if the message was consumed properly. Excuse me just for a second, guys, okay? I just need to open the door. Okay, guys, I'm back. And if there was something wrong with the message, and I already know this, I can handle this, I should return the reject. Of course, there is also how it should be handled, how it will be handled if it's run with few consumers, so it's a parallel, and some complex example on diagram, but I will show this you with the Xdebug for the export example. So let's enable the Xdebug again. Let's consume the queue. Okay, it's idle. And now let's execute the export. So what I did, I added some breakpoints and I did just one change. And okay, we have a lot of classes that I don't need at this moment. Let's do this like this. Here in the pre-export processor, when we split on batches, of course, there is a batch size defined in the container, and I just overrated, hard-coded to make 2. So despite the fact I have only 4 entities, there will be some chunks, okay? So that's only change I did here for the demonstration purposes. Okay, so let's go to the user namings. As you can see, there is really a difference when you run the application with Xdebug and without it. So whenever you don't debug something, just disable this. And also in another tab, I will open the jobs. So you will see when it is created. Right now, because my message queue is idle, in message queue table, there is nothing, okay? And in the, okay, so let's run it. So I export. And the consumption started. Actually, I think I have it. No trace here. Just a second. Okay, I have the breakpoints. Okay, that's weird. Okay, now it runs. Okay, so first of all, there was a message, and the message was consumed, and this message is calling pre-export message processor. So pre-export message processor, its responsibility is to check if the message is correct. So let's see the message. So I have the information what job should be executed. So I export entity to CSV. I have the information about the processor alias. So as you remember, we configured this yesterday. And who clicked the button, for example, right? But I'm checking if there is a message. Then in get message body, I'm checking the properties. And if the message is correct, I get some unique job name for this body. So there is some logic how to create this unique job name. So you can see it's Oro, import, export, pre-export, and then there is a job name and the user. So for each user to be different. And I run unique. Okay, so once I run unique, there is a message ID, there is a unique name that I generated, and some callback that will be executing this. Once I do this, as I remember, we already should have unique information here. So I have the information that this unique job is running. And if I try to do this again, no job will be created because there is only one unique at this time with the specific name. And also here in the jobs, oh, actually it didn't load. I should get the information about the job being created. I will check this in a second. Okay, so I'm checking IDs of the entities to export. And here, still in the pre-export message processor, but inside of this unique job already, I have the split on batch. Okay, so I got the IDs. There is 4 IDs because we have 4 entities. I set the batch size to be 2, so I should have 2 chunks. And as you can see, my IDs were divided to 2 chunks. Okay, then if this will be empty, I can do something, but it's not, so I have 4 each. So for each chunk, I create a child job. And in the callback, there is a message to process this child job. So for each, I'm creating the delayed job. It's adding the message to process this job. And another one. And something very important, there is something called dependent jobs. Dependent job is a thing that will be executed after all child jobs are done. So in this case, dependent job will get the summary of the child jobs, and we send this email with the link to the export you just did. Okay, so each child job will be executed in parallel. So if I would run few message consumers, one will take care of one and the other of another one, but this is not good for the debugging. So I'm using the one, and after both of those are finished, the dependent jobs will be called. Okay, let's check if it's refreshed. Yeah, you can see I have the root job, and inside checks in a second. Also here in the message queue, I have the messages to run those child jobs I had, and the message to calculate the progress of the root job. Here you can see for each chunk that was created child job, and this is the root that is running at this moment. Okay, so there was processor that was responsible for starting the export. It started their unique job. It got the IDs of entities to export. It created the chunks, and for each chunk there is a child job to process it. Let's continue. And I'm adding the dependent job. As you can see, the dependent job is the same. We have topics and some additional information. Now my message queue is being processed, and the first of those child jobs is consumed. And now I have export message processor, and this is for the chunk already. So here in the message, you will see I have the information about the job, I have the information, the alias, but also there is information about the IDs I should export. Okay, so this specific message will just export those two inside of this child job. We just export those given entities. Let's continue. As I told you, you need to, you need to run this in this run delayed or run unique. So whenever your message is done, it will change the status of the job. We check the message body, we decode it, and we run the functionality. So here we actually are going from the message queue to the import-export functionality. So here we are getting export handler. Inside this handler there will be processor, and it will do what we seen yesterday. So it will read the entities, processes one row after another, and return some results. We're not gonna see this in a second. As you can see, I have the processor information here, job name, and some configuration. Once this is done, and this is something very important, I'm saving the results of the job. So my unique job was executed, my child job, and in the results, I have the information of the file generated. So for each chunk, there is a separate file generated. I have the information of the records count. As you remember, it was displayed in the summary, and I have some information about the errors. And I store this to the child job. So once I do this, here in the child jobs, I would see this information. Why this is important, you will see in a second. I continue. Of course, everything went okay, the result is there, so I return acknowledged. The result is true. Now the second child jobs got processed exactly the same way. The difference is here in the message. You will see that I have different IDs. So this is the second chunk. So let's skip this. And once both of those messages were executed, let's just check the UI. Okay, I will check. Oh, wait. Always when I want to switch the tab, it's just refreshing. And there you go. So you can see the first one was done, and the second one is not yet finished, so it's running. And if I go to the job list, there will be progress bar for this root job, and it will be calculated based on the number of child jobs already done. We'll check this in a second. Oh no, actually, in a moment he will finish the second job, so it will be pointless. Okay, you can see there are 3 child jobs, 2 of them already success, so the progress is calculated. Now we finish this one. Once we finished both of the child jobs, there is this dependent job we set. And this dependent jobs is handled by the post-export message processor. Okay, so we had the pre-export that was creating all the chunks and the child jobs. Then the export message processors were executing each of those chunks. And at the very end, there is a post-export message processor. And what it does, the first important thing is here. So it has access to all the child jobs. And it gets this status from all the child jobs. So as you remember, each child job created a chunk of CSV file and had some summary. So what he does, he gets the iterate over all the child jobs. Then it merge all the files into one export file, okay? And also it creates the summary. So each child job in results said how many rows was there, was there errors or not. And at the end, it sent the email notification with the summary. And that's it, okay? So this is how it works. So you've seen how the message queue proceeds, and at each moment, it goes with the import-export functionality. And now it's consuming some other messages, and it's idle again. And once this is all done, we probably got an email. And there you go. So there is a one file because it was merged, those 2 chunks, in the post-export message processor. Okay, guys, some questions answered for you. And okay, Marcos, how can a consumer parent spawn more jobs that are related to as a children? So as I showed you, so you have the message is consumed by the processor, and inside the processor, this is where you have some logic. If you need to create some child jobs or not, if you do, you create these delayed jobs, and for each of those, you have the message to process it. And Santiago, the message only can be created with DB event? No. So you have this producer service. You can inject it to any event listener you want and send the message. That is, for example, on login, you can send the message to update the login count or something like this. Sure, no problem. So this is just a service. You need to create a topic. For each topic, you need to create a processor to do the logic. The practice for this, I will show you quickly tomorrow. Well, I will just show you the practice exercise, but I will show you the solution tomorrow. So we can start from something like not just from the theory, but from something to the solution, to see the solution. And actually, you've seen half of it during the presentation, but let's see. So the practice could be like this. First of all, we should add the field example to user naming type. You can really, it's good to work to practice the migration because you're gonna write a lot of those. And then every time user naming type is created or format is changed, you need to asynchronously generate the name example. So actually you've seen this process already, but I will show this in very detailed step by step tomorrow at the beginning of the webinar. And then you should just clean a little bit. So for example, you should generate this example for all the naming types in the fixtures. And also in places where you are generating this manually, you should just use the one generated and stored in the entity field. Okay, so we will see the solution to this step by step at the beginning tomorrow. Then we're gonna talk about the workflows. This is a really nice topic. And there is a plan for maybe 1.5 hour session of Q&A. Of course, if you will not have questions, we will just finish earlier. Okay, I don't see any more questions. So guys, from my side, that's it from today. Thank you very much. Have a good evening or day, depending where you joined from. And talk to you tomorrow at the last day. Bye-bye.